All right, module 8, intuition. This would be kind of a shorter one than usual, so that's cool. I guess the idea is this. Okay, here we go. Module 8. Da-da-da. We call this, we'll just call it systems of equations. Close enough. Systems of equations and inequalities, etc. Here's the idea. In the past, we're used to solving equations that have a variable, and we've of course gone nuts over that because, there was all this stuff about x to the 0, x to the 1, x to the 2, x to the 3, all these things, x to the -1, x to the half, we're trying to weird things, x to the 1.3, all these things that we did, and then we got into solving, transcendental functions, they call them, or whatever, with logarithms and all these things. Okay, new idea. Suppose now, what if we went back to even maybe simple equations at first, although they don't necessarily start or stay that way. But say we went back to the idea about super simple equations, and I was like, I'm thinking of some number, don't know what it is, right? Thinking of some number, but I give you a hint about what it is. And I say, well, if you plus 3 onto my number, you get 5. As soon as I give you that hint, it kind of like tells you everything you need to know. Because here, let's undo some of that. If I had just left it at guess this number, then we'd be kind of lost. And I was like, well, okay, I don't know. It's any number there ever could be at this point, because I didn't say anything, I just said, guess a number. I'm thinking of this number, it could be 1,000,000, we don't know. And so whatever, but if I give you a hint, like we were saying a second ago, if I say, when I take my number and I plus 3 onto it, I get 5. Well, that's a pretty good hint. If I give you a hint, then all of a sudden that narrows down my number, absolutely anything. So from some huge infinite set of guesses to, well, I know exactly what number it is. It has to be 2, 2 plus 3 is 5. There's only one number in the world that does that. Okay, this is our one variable stuff. And of course, you've seen how that gets complicated if we start doing weird things on there. Okay, keeping it linear for a second. And actually, well, we'll just speak about linear stuff here, just x to the 1, even though we do investigate a little bit further than that in this module as time goes by. Okay, but anyway, teeing it up, here's the idea. Suppose now, what if I had, instead of saying, my missing number, or my, I don't know what the number is, my unknown, and then I give you a hint about it. Suppose I was thinking we're playing a game or something, whatever again, and I'm thinking of 2 numbers, and I don't know what either of them are, or you don't at least, know what either of them are, or either is, I guess. And then I was like, well, okay, I'll give you a hint about it, and I said, well, okay, if I plus them, I get 5. Well, this is way better than it was a minute ago, because if you didn't have a hint about them, I don't have a clue about this one, and I don't have a clue about that one, If there's no hint about any of it, then this could be any number ever, and this could be any number ever, and I don't have any idea. But now at least I have a relationship between 2 of them established, I know that when I plus the 2 of them together, I get 5, and most numbers, you could say, don't do that. It already narrows down almost every combination you could think of. Most things don't add up to 5. It's not 7 plus 11, it's not 18 plus 13. It's not most things, most things don't add up to 5, but some of them do. And so we start listing this off. If I give you a hint about this, it helps us to narrow it down, but it doesn't narrow it down like it did on the last problem. When we had just one unknown, if I say, well, this plus 3 is 5, well, it's 2, whatever. It narrows down to automatically, I know exactly what's going on. Well, it's not the case here. If I have 2 unknowns, well, then we're like, well, let's keep track of, well, what does that narrow down to? It could be that this x is 5 and this is 0, 5 plus 0 is 5. It could certainly be that, or it could be 4 for the x, and then the y is 1, 4 plus 1 makes 5. And then all the other combinations that might come to mind too, 3 and 2, etc. So if we started taking, keeping track, we could be like 5 and 0, 4 and 1, 3 and 2, 2 and 3. Like you could have the X be the 2 and the Y be the 3, you know. Then it could be 1 and 4 or 0 and 5. And if you leave things at that and we're like, well, okay, we're strictly sticking to non-negative integers, I guess that's the end of the list, and that narrows it down a lot. But if we didn't give you that condition or whatever, then we'd say, well, okay, it'd be nice if the list stopped here, but there's no reason that it would have to. It could be -1 plus 6. You know, that also adds up to 5. And as soon as we start going in that direction, if we open up that can of worms, then, well, all of a sudden there's nothing stopping us. You know, I mean, -2, and there's an infinity number of combinations. And then of course it could get even more giant if you can get more giant than infinity. You know, there's plenty of conversation to be had about that. But you know, what if we were like, whoa, it could be 1.5 and 3.5, right? If we went into the fraction world, well, and that then it's like there's a million different things even in between any one of these combinations, you know. Well, it's infinitely many actually in between each of them. And so that is a whole other huger infinity number of ways that this could add up to 5, you know, because then it could be, you know, 1.4 and 3.6 and all these other things. And so now then we'll just have to put the old ... going on, because now we see that it's funny because, okay, we gave you a hint and we said, well, most things don't add up to 5. And that's true. Most things, I mean, in speaking in some kind of an intuitive sense anyway, most things don't add up to 5. If I'm thinking about combinations of two numbers, you know, it's narrowed down to just a very selective list of just things that add up to exactly 5. But we're finding out that list is gigantic. It's actually a huge infinity of combinations. You know, not only is it an infinity of them, it's a very, what we would, you know, maybe you would call a dense infinity or something. It's a big infinity, you know, without getting into, you know, real analysis and topology stuff about like, well, how do we characterize a bigger infinity and all this stuff, whatever about all that. What we could say though is that it's crazy because we've narrowed down the possibilities, but there's still infinity of them, you know? And so it doesn't really feel all that narrowed down all of a sudden, even though in a sense, we still got rid of most of the possibilities. And so I guess the lesson learned here is when we have two unknowns, well, giving us one hint about them is very, very good. It narrows down a lot, but it's also very, very not enough. Like there's no way I'm going to know exactly what these two numbers are if I have just one hint about it, if this is my only hint, you know. Good luck narrowing that down. We narrowed it down as much as we could, and there's still billions of possibilities, you know. And so, well, okay, here's where we go with module 8, is we say, okay, if you have two unknowns like this, then you got to figure out how to solve for them both. You're going to need two hints, you know. If you have one unknown, then one hint was enough, you know, one missing number, then one hint was enough to do it for us. If we have two unknowns, then we'll need two hints to narrow it down all the way to figure out what they are exactly. And so if I give you a second hint, say I said, if they, you know, these two numbers, they plus to 5, but what if I minus them, you know, then the X number minus the Y number, what if I said, well, that makes a 1, you know? And all of a sudden, everything narrows down wonderfully, because we had, you know, narrowed down to just these combinations before, which is actually a straight line pattern of combinations if you ever graph it on a Cartesian grid or whatever. Interestingly, well, who cares? Anyway, we narrowed it down, but there were still infinity many of them. And now the second hint give us a huge amount of clarity, because not only is it things that add up to 5, which is all of these combinations, but now of the ones that we've listed, you can tell if you look over them, which one is going to be the winning combo, because 5 minus 0, you know, 5 plus 0 does equal 5, but 5 minus 0 does not equal 1. These don't just subtract to 1. 4 minus 1 is 3. That doesn't make a 1. 3 minus 2, bingo. That's the guy. three plus two, we knew it made 5. That's why it was on the list. But 3 minus 2, when I minus them, I do get a 1. 3 minus 2 is a 1 at the same time as 3 plus 2 is a 5. And so that is the perfect combo we were looking for. And what we noticed is that that's the only combination that does it. None of these other ones do. Nothing, and most of them aren't even close. And so I guess what we learn about this in module 8, this is the theme, is that when we get more unknowns like this, numbers that we don't know of, and we're supposed to solve for them, well, the more of them you have, the more hints that you need along the way. So if I have 2 unknowns, I'll need 2 hints in order to make this work. If we have 3 unknowns, X, Y, and Z or something, then we'll need 3 hints to narrow this down to know exactly what numbers each of them is. And so we have, in this case, it became a 3 for X and a 2 for Y, worked out well. And so that's the idea behind all this stuff. And of course, as we get into nonlinear stuff with X squareds and this and that, that complicates a little bit more on the number of solutions and this and that. But this is still the idea, even with those. If I have 2 unknowns, I'll need 2 hints with that, and 3 unknowns is 3 hints. And then the rest of everything that we do in the module is all the nuts and bolts are just techniques about how to narrow this down, because of course, well, that's the difference between, getting this intuition idea about this story behind it all and how we get this done in the trenches, Anyway, that's all I got to say about this. I think that's the idea behind module 8.